Good morning, everybody. Yesterday in maths we started to look at some capacity, and today we're going to continue that and we're going to talk about capacity and volume. We'll start off by talking about the word capacity. Now, capacity means the amount of liquid that a can or a bottle or a bath or a swimming pool or anything like that can hold before it's full. So, for example, I have here a can of Coke, and you can see that the capacity of this can of Coke is 330 millilitres. You can put 330 millilitres of liquid inside this before it gets full. I also have here a bottle of water, and the capacity of that bottle of water is 500 millilitres. That means that when full, it can hold 500 millilitres. So we can say that the capacity of the can is 330 millilitres and the capacity of the water bottle is 500 millilitres. The can has the capacity to hold 330 millilitres. That's how much it can hold before it gets full. And the water bottle has the capacity to hold 500 millilitres. Now, that doesn't necessarily mean that there's always exactly 500 millilitres inside the bottle. If you take a close look at this bottle, you can see that it's half empty, there or thereabouts. So although it has the capacity to hold 500 millilitres, the volume of water inside the bottle is not 500 millilitres at the moment. The can has the capacity to hold 330 millilitres. It hasn't been opened. So right now it's full, and the volume of liquid inside the can is 330 millilitres. It contains 330 millilitres at the moment. After I finish my lunch, it won't contain 330 millilitres anymore because I will have drunk it. So the volume of liquid inside the can will be 0 millilitres because it'll be empty, but the capacity of the can will still be 330 millilitres because that's how much liquid it can hold. It's sometimes helpful to think of the word capacity as being very similar to the word capability. So capability means your ability to do something, and capacity can mean the same thing. For example, you could say, John has the capacity to understand very difficult maths problems. That means he's capable of doing it. He has the ability to understand very difficult maths problems. Or the runner has the capacity to do the marathon in record time. He has the capability, the ability to do that. So the can of Coke has the ability to hold 330 millilitres and the bottle of water has the ability to hold 500 millilitres. It doesn't mean that they always are holding that amount, but it means that that's what they are capable of. They have the capacity to hold that amount. So when we talk about the word volume, that means the amount of liquid that's actually inside something. Now, this measuring jug that you can see has the capacity to hold just over half a litre of water, but the volume of water inside the jug is 200 millilitres. If I read my measuring scale there, I can see it's 200 millilitres. So the volume of water inside this jug is 200 millilitres at the moment. That's the amount of water or liquid of any kind that is actually inside it. But when we talk about volume, we don't necessarily have to be speaking about liquid. Volume just means the amount of space inside an object. The amount of space inside an object. Or, to put it another way, the amount of space that an object takes up. So the amount of space that an object takes up. Now, when we measure volume, we do it in centimetres or metres cubed. Centimetres or metres cubed. For example, I have here a cube, and the volume of this cube is 1000 centimetres cubed. Now, what does that actually mean? Well, what that means is that that's the amount of space the cube takes up. I'm measuring this in centimetres cubed. So whenever I say that it is 1000 centimetres cubed, that means that it would take 1,000 centimeters, cube centimeters, just like that little one there, to make up this big cube here. So I'm using centimeter cubed to measure the volume, and 1,000 of those would make up this cube. So the cube takes up 1,000 centimeters cubed. That's the amount of space it takes up. If we were looking at objects which are much larger, we may measure them in meters cubed, but for most things we'll be working in centimeters cubed. So that cube takes up 1,000 centimeters cubed. 1,000 of those little cubic centimeters would have to go into making up this cube here, 1,000 centimeters cubed. Now, how do you work out that you need 1,000 of those to make up that cube? Well, thankfully I didn't have to put 1,000 of those tiny cubes together and see if it was the same size. There's a formula for volume which we use to work it out. And the formula is a bit like area, but it's one step further. If you think about area, we measure it in centimeters squared. In volume, we measure it in centimeters cubed. So where with area, our formula is length times width. With volume, our area is length times width times height. We talk about area in centimeters squared because there are two dimensions, length and width. But we talk about volume in centimeters cubed because there are three dimensions, length, width and height. And we multiply those all together to find the volume. Let's take this cube that we have here as an example. So the length of this cube, and it doesn't really matter which part you count as length, but I'm going to count this size facing here is 10 centimeters. The width, if you count it up carefully there, I can see it's also 10 centimeters. And the height, so the height of the cube, not a very straight line there, the height of the cube is also 10 centimeters. And I have to multiply those all together to find the volume. So the length is 10, the width is 10, and the height is 10. 10 times 10 times 10 is 1,000, so my volume is 1,000 centimeters cubed. So in P6 we've been looking at our Rubik's Cube, and I had a little measure of my Rubik's Cube just to see out of interest, and each cube on the Rubik's Cube is slightly more than 1 centimetre. But if we used our imaginations and we said that each cube on the Rubik's Cube was 1 centimetre, then I could work out the volume by using my formula. I could say that the Rubik's Cube is 3 centimetres long, 3 centimetres wide, and 3 centimetres high. So length times width times height is my formula, which is 3 by 3 by 3. Now, hopefully a lot of you have spotted that this ties in with something you've been learning in your tables, which is cubed numbers. Another way of saying 3 times 3 times 3 is 3 cubed, which is 27. 27 is 3 cubed. So the volume of this Rubik's Cube would be 27 centimetres cubed. So looking at a cube is actually a really good way of visualising what cubed numbers actually mean. Here we have another cube. You know from your 2D shape facts that the sides of a square are all the same. And you know from your 3D shape facts that the edges of a cube are all the same. So this cube, the length, width and height are all 4 centimetres. We know that because all the edges are the same measurement. So length times width times height will give us our volume. And we know that's 4 times 4 times 4, or 4 cubed, which is 64. So hopefully you won't even have to do a sum for that because you'll remember it from your table facts. But 4 cubed is 64, so we can say that that cube is 64 centimetres cubed. Our formula also works for cuboids. So if we want to find the volume of a cuboid, again, length times width times height. Now, if measuring this cuboid, we find that the length of the cuboid is 3 centimeters, and the width of the cuboid is 7 centimeters, and the height of the cuboid is 3 centimeters, because this end square face here is a square, so all the sides are equal. Then could we work out the volume of the cuboid? Pause the video now, have a wee go, and then play the video again and see if you were right. Okay, so hopefully you've had a go at working out the volume of this cuboid. Length times width times height, 3 times 7 times 3. It doesn't matter which way around you do your multiplication, so I'm going to make it as easy as I can for myself. I'm going to stick to my tables. I know that 3 times 3 is 9, so I still have to multiply that by 7. And I know that 9 times 7 is 63. So the volume of this cuboid is 63 centimeters cubed. Just to do it another way and prove that it works whichever way around you do it, I could start off by doing 3 times 7, which I know is 21, and then multiply that by the remaining 3, which again gives me 63. So it doesn't matter which way around you do your sum, as long as you multiply all those numbers together, that will give you the volume of the cuboid. This is your main learning video today. In the next video, I'm going to talk through some specific examples from today's problem solving.